All right, so let's cover some fraction simplification. Here we have an example of 3x plus 6 over 3x, and our job is to see if we can actually, simplify this fraction in any meaningful way. So there's basically two principles you need to know for fraction simplification, and one is that if the numerator has, or the denominator for that matter, but particularly if the numerator has terms separated by a plus or minus, you can't just divide stuff out simply. So in this case, it might be a little bit tempting to just divide out 3x with 3x and be left with 6. You can't do that. That's incorrect. The rule is you divide, when you have several terms on the top, you divide each term by the entirety of the bottom. So in this case, what would that look like? So here, this means you would be given, or you would get, so first term, 3x over 3x. What's that? 1, right? That's going to be 1. Then you take the sign you have over here, so plus your second term divided by what you have on the bottom. So 6 over 3x, you're going to get 2x. I'm sorry, 2 over x. 2 over x. So that would be how you simplify this. Again, in this case, is that a useful simplification? Somewhat, but let me show you an example where it would definitely very clearly simplify your equation. Let's say you have x plus 2 times x minus 3 over x minus 3. Okay, so here we have two factors being multiplied together, right? They're not being added, they're not being subtracted, they're being multiplied together. So in this case, we can actually divide stuff out. So we actually see that, luckily, our denominator is actually equal to one of the factors that we have on top. So that means in this case, because these are bound together by multiplication, we can divide stuff out. So x minus 3 would divide out with x minus 3 on the bottom. So this would be like 1, right? So this would mean that all you have left is x plus 2. X plus 2. Let's do another example of something similar to this. Let's say you have, why don't we combine these two actually, right? So let's say you have 3x plus 6 times x minus 3 over 2 times x minus 3. Okay, so you've got quite a bit of stuff going on here, but again, what do we see? We see that we have on the top two factors being multiplied together, and on the bottom you also actually have two factors being multiplied together. Now, you could distribute this 2 out, but I would say just hold off on that, right? Because since it's not distributed, we see that we have an x minus 3 here and an x minus 3 here, right? The question is, can you actually factor those out? Well, based on what we just learned, if the top is bound by multiplication, and here so is the bottom, you can divide it out. So that goes to 1, so you're just left with 3x plus 6 all over 2, right? So you have this part left and this part left. Okay, good progress, but we're not done yet because we can simplify this even further, right? Very similarly to how we did it up here. When you have it separated by a plus or minus, what do? You take each term on the top and you divide it by the entirety of the bottom. In this case, the entirety of the bottom is just 2, so you would do 3x divided by 2, so that would be, let's just move over here, that would be 3 over 2x, right? Or, you can put the x in the numerator, both are equal, plus your second term divided by your numerator, so 6 over 2, so it'd be plus 3. Okay, let's go over a few more examples to, again, show some other variants that you can have that will appear on the SAT. But basically, with those two principles in mind, you can pretty much simplify any problem you'll need to on the SAT. But to sort of solidify that, let's do a few more examples together.